Hello Algebra 2 students, this is your Unit 3 review, and we're going to start by graphing a quadratic inequality. So the inequality here tells you that you're going to be shading all of the answers. Let's start by finding the vertex. You're going to use negative b over 2a to find the x-coordinate of the vertex. So remember, this is your a, b, and your c. So that would be negative 8 over 2 times 2, negative 8 divided by 4, which is negative 2. So negative 2 is the x-coordinate. To find the y-coordinate of your vertex, you plug the negative 2 back into the original. So 2 times negative 2 squared plus 8 times negative 2 plus 3. So this would be 4 times 2, which is 8. Minus 16 plus 3, negative 8 plus 3 is negative 5. So the vertex has an x-coordinate of negative 2 and a y-coordinate of negative 5. So we're going to go to negative 2 and negative 5 and make the vertex. The a value is positive, which means that the graph will open up, and it has a stretch of 2. So that normally your parent function parabola goes over 1 and up 1. So that would be your vertex, over 1 and up 1. And your parent parabola normally would go over 2 and up 4. That's your parent parabola. So instead of going over 1 and up 1, we go up twice as much. We go over 1 and up 2. And then normally we would go over 2 and up 4, but we're going to go twice as much. We're going to go over 2 and up 8. So we're going to go up from negative 5 all the way to 3 on both sides. And then it says that y is greater than, not greater than or equal to. So anytime you have greater than or less than with no equal sign underneath, you need to remember to use the dashed line to not include the line. So I'm going to do a dashed parabola. Do your best to make it look U-shaped and not V-shaped. Alright, and then it says that y is greater than. So this means greater, and if you want the values greater than the parabola, you shade above it. So I'm going to put the pointer on the parabola and go up from there. So up. This is me shading above. So any point that's in the shaded region is a solution to the quadratic inequality, meaning that any point where I plug in the values for x and y would make this sentence true. Alright, when you have a quadratic system that's graphed, you can find the solution just by finding the intersections of the points. So this point over here, it looks like it has an x-coordinate of negative 1 and 1, 2, 3, 4, negative 4. And over here, it would be 1, 2, 3, 4, comma 6, it looks like. 1, 2, 3, 4, 5, 6. So 4, 6. In 3, we have to solve the system algebraically, which means we're not allowed to graph it. So let's see, both equations equal 0. So if they both equal 0, you could say that they equal each other. So that's one way to do it. We could solve this with substitution by just saying 5x plus y minus 8 equals negative x squared minus y plus 4, and that would be using substitution. You can also use elimination, and that's when you would add the two equations together. So that's a different method. Elimination would be if I took 5x plus y minus 8 equals 0, and I added the equation negative x squared minus y plus 4 equals 0. And the reason why elimination would also be a good choice is because if I added these two equations together, my y's would cancel out, leaving me with just one variable. So I'll go ahead and solve both ways and see which way seems better. With substitution, I have, let's see, a negative x squared on this side. I'd like my x squared to be positive, so I think I'm going to move everything over here. The problem is, if I solve this, I'm going to end up with both x's and y's in this equation. So I'll add y over here, and I'll end up with 2y. And I still have all these x's. So I'm going to decide that substitution is not a good method here. And instead I'm going to try elimination. Because what happens here is my y's will cancel out. So I'll add these two. They're not like terms. So I just get negative x squared plus 5x. I'll add these two. And those are like terms and they cancel out. And then I'll add these two and I get negative 4. Alright, so this looks like something I can factor, but I don't like to have a negative leading term, so I might just divide both sides by negative 1 to get rid of my negative leading term. So if I divide by negative 1, all my signs change. This changes to positive x squared, this changes to negative 5x, and negative times negative divided by negative is positive 4. So now I'm looking for numbers that when I multiply them, I would get 4, and when I add them, I get negative 5. So for 4, I'm thinking about 1 times 4, 2 times 2, but to add to a negative, then you would have to make both negative. Negative times negative is still positive. So negative 1 and negative 4, those numbers also add to negative 5, so I can factor with those. My factors are x minus 1 times x minus 4 equals 0. And when I solve those, x minus 1 equals 0, x minus 4 equals 0, I get x equals 1 and x equals 4. But that's not enough information because I need to know the points, like up here. I need to know the x and the y. So I'm going to take my two x's and I'm going to substitute them back in to find the y values. And I have two choices. This one has an x squared and this one doesn't have an x squared, so I'm thinking the first equation might be simpler. So I'm going to plug in 5 times 1 plus y minus 8 equals 0. 5 times 1 is 5, and 5 minus 8 is negative 3, so I have y minus, so y minus 3 equals 0, and then add 3 to both sides and I get y equals 3. So this point would be 1, 3. The x is 1, the y is 3. If I put the 4 in, I would have 5 times 4 plus y minus 8 equals 0, which is 20, plus y minus 8 equals 0. 20 minus 8 is 12, so y plus 12 equals 0, and y would equal negative 12. So I have x equals 4, y equals negative 12, and that point would be 4, negative 12. So there's a lot of work here. Box up your answers so you can find them. Okay, here's another system to solve algebraically. This time, both equations equal y. So if I set this equal to this, then both of my y's are gone, so substitution might be a good method this time. The reason why I can set the two equations equal is because they both equal y. So if they both equal y, they have to equal each other. So I have x squared plus 3x minus 6 equals negative x squared plus x minus 18. I'm going to add x squared to move it to the left, and I'm going to move everything to the left. So I'll move the x to the left, and I'll move the negative 18 to the left. And that way, one side equals 0. I have 2x squared plus 2x plus 12. I can see I have a common factor of 2. I'm just going to divide both sides by 2 to get rid of that. I have x squared plus x plus 6 equals 0. And then I need numbers that multiply to 6 and add to 1. That's going to be tricky. Okay, so I see that I actually miscopied this one. This one's supposed to be a plus 18. So if I know this is a plus 18 from here, that means I'm actually going to be subtracting 18 here and subtracting 18 here, which will give me negative 6 minus 18 and negative 24 here. And negative 24 divided by 2 is going to give me negative 12. All right, so maybe this will work. I need numbers that multiply to negative 12 and add to 1, and those numbers would be 4 and negative 3. So I get x equals negative 4 and x equals 3. And then I need to substitute them in. So the equations look about the same. I'll use the first one since the x squared is positive there. So it's going to be negative 4 squared plus 3 times negative 4 minus 6. 3 squared plus 3 times 3 minus 6. 16 minus 12 minus 6. 4 minus 6 is negative 2. So my y is negative 2. And my x is negative 4. This one I have 9 plus 9 minus 6. 18 minus 6 is 12. So I have 3, 4. All right. In number 5, this is a review problem from the last unit. This is your intercept form. Remember, intercept form would be y equals a times x minus p times x minus q. So the x-intercepts are the opposite of these numbers, opposite of negative 2 and opposite of 4. So that would be x-intercepts at 2 and at negative 4. So 2, 0, negative 4, 0. The axis of symmetry is halfway between them. So if I count in on both sides, I can count in 1, 2, 3, 1, 2, 3, and this would be my axis of symmetry halfway between them, where all the x values are negative 1. So x equals negative 1. So negative 1 is also going to be the x-coordinate of the vertex. It's going to be somewhere on this line, and I plug negative 1 into the equation to find the y. So y is going to equal negative 1/2, negative 1 plus 4, negative 1 minus 2. All right, so it looks like negative times negative, I'm going to get a positive y value of 9/2, which is about 4.5. It's actually equal to 4.5. So my vertex is negative 1, 4.5. Negative 1, 4.5, which means that, oops, that's a negative 4.5. Sorry about that. 4.5. So that means my parabola goes through my vertex and it goes through these x-intercepts. Okay, so we can actually check and make sure we graphed it correctly by graphing on the calculator. So negative 1/2 x plus 4 x minus 2. Let's clear what I have in here and let's put in negative 1/2 x plus 4 and x minus 2. Alright, so graphing it, I think it looks the same. Let's just take a quick look. Yep. And if you want to be extra sure, you can look at the table of values. So press second, graph, and I can see my x-intercept at 2, and there's another one at -4, and I can see my vertex at -1, 4.5, so that looks good. All right, to simplify the radicals, you want to break them into their prime factors. So 700 would be 7 times 100, and then 100 would be 4 times 25, and 25 is 5 times 5. So anything that appears twice can come out of the radical. So the 5 can come out, and that would leave 7 times 4 inside. So that would be 5 root 28. In problem 7, normally I would just multiply under the radicals first and then I would simplify, but 27 times 30 seems pretty tricky. So I know I can simplify the square root of 27. I'm going to do that first. So square root of 27, I'll just do that in the margin. That would be 9 times 3, which would be 3 times 3 times 3. So I have 3 3's. 2 of those 3's can come out. So square root of 27 can be written as 3 root 3. So I'll have, for all of this, 6 times 3 root 3 times 4 root 30. So 6 times 3 is 18. 18 times 4 would be 40 plus 32, so 72. Root 3 times root 30 is root 90. All right, then the square root of 90 can also be broken up. So I'm going to do that over here in the margin as well. Square root of 90, 90 would be 9 times 10. 9 is 3 times 3, and 10 is 2 times 5. So I'm going to take a 3 out there. So I have 72 times 3. 2 times 5 would be root 10. So this would be 210 plus 6, 216 root 10. All right, in number 8, we have a negative under the radical. So we know that's going to give us an I. So we're going to take the negative out, and it's going to be I root 56. Now we want to break the 56 up. So it could be 28 times 2. 28 could be 14 times 2, and 14 could be 7 times 2. So I have 7 times 2 times 2 times 2. So these two can come out, and I would have 2i square root 14. All right, let's see what page we're on. So we have one more page to go. Okay, in number 9, we're going to subtract like terms. So 3i, I can minus the negative 3i. 3i minus negative 3i. And minus negative makes plus, so I get 6i. Negative 6 minus 17 is negative 23. So my answer would be negative 23 plus 6i. Now you can check your answer on the calculator if you put your calculator in A plus BI mode. So if you press mode, you want to go from real mode to A plus BI mode. So go down to A plus BI, and you need to, press enter. All right, and then we can press parentheses. Sorry, I'm losing that. To get the I, you're going to press second and then the decimal, and then minus 6, close your parentheses, minus parentheses 17, minus 3, and then to get another I, second, decimal, and close, and you can check your answer this way. So negative 23 plus 6i was right. In problem 10, we are going to square 4 plus 7i. So to square it means to multiply it by itself. You cannot just square each term, that just doesn't work. So 4 plus 7i times 4 plus 7i. 4 times 4 is 16. 4 times 7i is 28i. 7i times 4 is another 28i. And 7i times 7i is 49i squared. So that should have an I as well. So these two are like terms, they combine. So I have 16 plus 56i plus 49, and I can replace -1 for I squared. So remember that I is the square root of -1, so that means I squared equals -1. So this is going to give me a -49, which I can combine with a 16. -49 plus 16 is -33, and I still have a 56i. And again, you can type this one in your calculator once you're in A plus BI mode. So if you type this on your calculator, you should find the same answer. Unfortunately, typing on the calculator doesn't really give you much you can work with if you have I to the 257 power. Your calculator is going to give you something that looks a little funny, and it could be something that you could deal with, but there's a better way around that. What we're going to do is we're going to remember that I to the 1 is I squared is -1. I to the third would be I squared times I to the 1, so -1 times I, it's -I, and I to the fourth is going to be -1 times -1, so it's going to be +1. So whenever you have a problem like this, you want to take out the biggest multiple of 4 you can. So I know 240 would be a multiple of 4, 248, 252, 256. So I'm going to make my I to the 257, I to the 256 times I to the 1. So any multiple of 4 is going to give you just the number 1. So 1 times I to the 1 should just give you I. In this section, 12 through 15, we're solving by finding the square root. So you need to isolate the squared value first. So I'm going to get rid of the +6 with a -6. And then I'm going to divide by 12 on both sides. And I have x squared equals -4. So you're going to solve with a square root. Whenever you solve with a square root, remember your plus or minus. So square root of a negative gives you the I, so I get x equals plus or minus 2i. Okay, in 13, it's the same idea. I'm going to get rid of the 45, so subtract the 45. X squared equals 17 minus 45, -28. And you're going to take the square root of both sides. Remember your plus or minus. Square root of -28. And the negative will come out as an I. 28 we can simplify. So let's think about 28. 4 times 7, and the 4 will be 2 times 2. So we can take that 2 out. So the negative comes out as an I, and the 2 comes out as well, and the 7 is left underneath. So plus or minus 2i root 7. Okay, in problem 14, the squared term is already isolated, so I'm just going to square root both sides, and then plus or minus the square root of -25. I have 2x minus 6 equals plus or minus 5i. I'm going to add 6 to both sides. 2x equals 6 plus or minus 5i, and divide by 2. So x is going to equal, these are two separate terms, but this one won't simplify, so I'm going to just leave it as x, 6 plus or minus 5i over 2. And then for problem 15, when I do the square root of both sides with plus or minus, I get x minus 5 equals plus or minus 2. So x equals 5 plus or minus 2. So I can actually do this problem. 5 plus 2 would give me 7. 5 minus 2 would give me 3. So my solutions are 7 or 3. Okay, and last one on this page is to find the discriminant. The discriminant is part of the quadratic formula. Remember that the whole quadratic formula is going to be x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So the discriminant is the part that's underneath the square root, not including the square root, just the b squared minus 4ac. So the discriminant is going to tell you if your solutions are real or imaginary, because if this is negative, it's going to give you an I, and that will give you your complex or imaginary roots. And if it's positive, it's going to give you your 2 real roots, and sometimes it happens to be 0. And if it's 0, remember that plus 0 or minus 0 would give you the exact same answer, so you would only have 1 real root. So here's your A, negative 3 is your B, and 2 is your C. So if I'm going to do b squared minus 4ac, I would have negative 3 squared minus 4 times 3 times 2. 9 minus 24, which is negative 15. So my discriminant is negative 15. Because it's negative, that means when I do the square root, I'm going to get an I. So I have 2 solutions, and they're imaginary or complex. Alright, so that's the end of the first 3 pages, and there will be another video for the last 3 pages.